Welcome back, guys. So we are here now with another video lecture, and this time we are talking on polymorphism. Poly in Greek, you can say many forms, or you can say like this: one method, many action. That is what we say. Polymorphism is all about. Poly means many forms or many methods. Phism means activities. So many activities or many forms, many actions. So one method, many actions is polymorphism. So let us understand with some examples. Let us consider behavior of a dog. Dogs, you must have seen. A dog can smell owner, a family member, and it wags its tail. So whenever it finds something friendly, it will wag its tail. But the smell is of a danger, it barks. If it is a food, then it runs for it. And if it is trained to detect explosives, the same smell can help the dog to detect the explosive, and they would bark or try to dig it out. So if it smells shoes, it can even find the owner, and it can even find the shoe within the stack or heap of shoes, right? So different actions for the smell is polymorphism. This is a very simple example to understand. Since we have seen dogs and the behavior is well known, it is very easy to understand. Always try to relate object oriented with the real world, and you'll be able to understand the concepts clearly. Okay. Now, we human, everything comes to human, and that is what I have to do. I bring it back to human only because that was the idea behind object oriented. So human, they are the best example of polymorphism, and since we are able to perform different actions at the same time, you must have seen people walking on the road, and you can see that the person may be waving at his friends, the person is looking at the mobile, talking at the same time. If you have earphones, earplugs, headphones, you're listening to music, you're talking, you're signaling, you're walking, even typing text, a lot of actions performed while walking only, right? So various actions you can perform simultaneously, and you know that very well. You're listening right now, you may be noting down right now, or you may be doing something else also right now. So polymorphism is performed every day and everywhere. And to look at it more closely as far as your codes are concerned, if you have you must have, actually not if you have, you must have definitely played some type of game on your system or your mobile, uh, and that is a very good example of polymorphism. Okay, so many actions are performed simultaneously, and but you feel that only one action is going on, but actually different actions are performed, and these actions actually we thread them, and there would be a nanosecond of delay, but still the action would be there, and you get a feeling that everything is working at one go. Okay, so background things are working, and we'll be seeing the polymorphism through examples also. So let us look at it further. It allows, that is polymorphism, allows objects of different classes, there would be different classes definitely, to be treated as objects of a common superclass. We'll be coming to superclass, base class, and subclasses in the next video lecture, that is would be on inheritance, because there would be certain keywords required. So I'll be talking about the superclasses in that. So for now, just understand superclass would be a parent class. So it enables methods to be defined in a generic way that can be implemented differently by different classes. Now, polymorphism actually allows coder to reuse the code. They give flexibility and extensibility by providing the ability to write code that can work with objects of multiple types. right? So polymorphism is a very important feature of object-oriented programming. We have 4 pillars, and one of the pillar is polymorphism. Okay, so we have different classes since the keywords will be coming, and we have to note down, keep them in mind. So we should understand that also. Although we have covered classes and objects and methods also, but certain things you have to keep in mind. Now, in this case, we are talking about concrete classes, abstract classes, interfaces, static classes. These keywords will be coming, nested classes, inner classes, anonymous classes. So these will be coming. So, and utility classes also. So these will be coming. So we should understand it. And that is the reason why I have not put in the classes videos. So wherever it is required, whatever is required will be added in the video, right? So concrete class is actually a regular class. You can note it down, or since the video is there, you can look at it again, but it would always be better to make your notes. Okay, a concrete class is a regular class that can be instantiated to create objects. Okay, you can create objects. It provides a complete implementation of all its methods and can have both data members, that is attributes, and methods with defined behavior. Okay, now then we have the abstract classes. Now these classes, we'll be talking about abstraction in the coming videos, but for now just understand this. Abstract classes, they are the classes that cannot be instantiated directly. You cannot instantiate them directly. It serves as a blueprint for other classes and may contain abstract methods, that is method you don't want others to access, that subclasses must override. So what it happens, it is a blueprint for other classes and may contain abstract methods, that is methods without implementation, that subclasses must override. Abstract classes cannot be instantiated because they may have incomplete functionality. Okay, then we have the interfaces. They are not like what we have, but they are very interesting part and important part. So an interface, it is a special type of a class that contains only abstract methods and constant fields. An interfaces define a contract of classes for classes that implement them, specifying what methods those classes must provide. Multiple interfaces can be implemented by a single class. A single class can implement multiple interfaces. So interfaces, that is the constant fields we have here, and abstract constant methods, and constant fields, that is variables with a static and final keyword. So these are your constant fields, that is variables with a static and final keywords. Okay, then comes the static class. A static class is a class that contains only static members, that is methods and fields. Static classes are used to group related utility methods or constants that are not specific to any particular instance of the class. They cannot be instantiated, they cannot be instantiated, and their methods and fields can be accessed using the class name directly. So you just have to use the name class name and use it like we have seen in the previous lectures. So you don't need to create an object, you can directly call them. That means instantiation is not required. Okay, then we have the nested classes. Nested classes, that is a class defined within another class. Nesting, that is what nesting is all about. It can be of any type, it can be concrete, abstract, or interface, and is used to logically group related class together. Nested classes can have access to private members of the enclosing class, promoting encapsulation. Okay, we have talked about encapsulation, I've seen it also. Then we have inner class. An inner class is a specific type of nested class that is not static. It has access to the instance members of the enclosing class and can be used to create multiple objects that are associated with the different instances of the enclosing class. Then comes your anonymous class. So anonymous class, will be looking at these from time to time, and you'll be able to understand it more. But just keep these these names in mind so that you don't get confused later. So an anonymous class is a special type of class that does not have a name and is defined and instantiated at the same time. It is often used to provide implementation for interfaces or abstract classes in a concise manner. Then comes your utility class, a class that contains only static method and no instance variables. There would be no instance variable. Anonymous class is a special type of class and does not have any name. But in utility class, it contains only static methods and no instance variables, and utility classes are used to group related utility functions that are not specific to any particular instance of the class. So these are the different type of classes in object-oriented programming, and you should keep a note of this. That is why I have put remember. So you should be able to remember them, and you can make a note actually, and you should try to remember all of these. Okay, so let us go to the next one now, and let us see the example. We have an example code of sum. Add function is there. You can see that there are two functions. One is one add here with different parameters. You can see it has double, it has no parameter, it has a static value, that is defined value, not static. You can say x is equal to 6 and y 10. Why I said static actually, because 6 and 10 are fixed in this case, so you can say constant values. Okay, you're returning x and y. So method add, that is method add, is returning x plus y in both the cases, but in first case it is an integer value, but in the second case it is a double value. Okay, so we have the main class now, and we create an object of sum, that is your base class. We call it base class or super class also in some cases, and parent class also in some cases. We'll be talking about this in the next video. And then we call the method add and add. In first case, we don't pass any parameters, but in the second case, we are passing 6.5 and 8.5. You can pass any value you want. And let us run this code and see how it works. So we'll work, see 6 and 10. The values can vary. In this case, I'm passing on 6.5 and 8.5. And in this case, the values are 6 and 10. So the base class is there, we run it, and what we get is we have 2 here, add and add 6.5. So 2 outputs will be there. One is 16, that is 10 plus 6, 6 plus 10 you can say, and 6.5 plus 8.5, that would be 15. Since it is double, so you have 15.0 or 0. Okay, so this is one of the examples of polymorphism. Very simple example. Here you can see these two methods, add and add, are same, and we call them method overloading. That is, you are overloading one method to do different jobs. Okay, so let us look at one more example where we will be having constructor overloading also and method overloading also. Combine them together and see how they work. So in polymorphism, definitely you'll have overloading concept. So let's have this example. I've already put the examples to save some time. You can note them down, or they will be with the lectures. So you can note them down and work on it. So this is a math operations. We have variables result integer and result double. Two results we are having. One is integer and one is double. Like this, we have integer result and double result. But here, little difference will be there because we have now constructor, and that is math operations with the integer a, b. We are passing the values here, result integer a plus b. We are putting it directly. We are not putting it anything else, but simply calculating it. So we are putting the function here to calculate. Then we are passing double values again. Result double will be a plus b, result int and result double. It is always better to put the data type with the variables so that you understand it later when you pass on or when you pass on the code to someone, or you look at your code only after some time. Okay, now we have math operation. We have constructor overloading. Again, we are having here, we are passing boolean here, integer a, b, boolean, we are passing a minus b. This is actually subtraction, and we are passing a boolean value also, and just for the sake of it, nothing else. It is not doing anything else as such, but just passing on. Okay, so we have four constructors here. One is for addition, two are for addition rather, and two are for subtraction. One is for integer and one is for double value. Okay, so four constructors and one method to display the result. Okay, so we are not overloading the method, but we will be reusing it. Okay, so that is polymorphism is all about. Now, just have a look at it again slowly. See, method, math operations, you have two constructors for adding and two construction for subtraction. One is with integer, the other is with double value, and we are passing on the boolean just for the sake of it. Okay, and then we are printing using display result function method. In our case, it is a method. Okay, so now we have the main method, and in that we create constructor. The four constructors will be required in this case because we have four parameters to pass. Okay, one is integer for adding, one is double for adding. Then in this case for subtraction, we are passing two integer, one time integer, one time double, and then we are passing the boolean also, true, true, true. You can have false, false, false also, and you try with that. Okay, and then we are calling the method display result, display result, display result every time, but your object is different. You can see one is add int, then addition double, subtract int, and subtract double. So your object is different, but your method is same. Okay, so let me run this code now. So the ways you can see your result is there. Okay, 15, and so whatever you are passing on, that result will be displayed. Okay, so display result, in this case some values we are passing which is giving me 0. That is okay. This is just for the sake of example, so we are just getting the feel of how polymorphism works. So it depends on the value I'm passing. So whatever value I'm passing, that will be done. In this case, actually it is minus. You can have it 5. 5.7. Okay, so now you have different values. You can change the parameters and see what results you get. So whatever you're passing, that will be definitely used here. And a minus b, a minus b, a plus b, a plus b, boolean you're passing. If you pass 4, it's okay. A is bigger. You can have 8.5 and so on. You can just have the results. Okay, so it may vary, and you can have true instead of this. You can have false also. You can have false. That's okay. And if I run it, you get a false. So result will be definitely there, but whatever I'm passing, that will be computed and result will be displayed. Okay, so this is what polymorphism example would look like. Okay, so you can practice this and you can have more examples, and you can practice more examples like this. You can have your own constructors and you can design your own methods. You can have overloading, method overloading, or constructor overloading. Okay, so this is what we have in polymorphism. I hope you would have understood what polymorphism is all about with the examples. So next lecture is on inheritance, and we'll be talking about a lot more things in that, some classes, type of classes also. So till then, have a nice day. Enjoy learning, keep practicing. Have a nice day.